Hello everyone, my name is Bharat and this video is a tutorial on how to build classification models on SAS. Today we'll look through the UI of SAS Enterprise Miner and see few how to build few diagrams and few models which helps us to build few algorithms for classification models like decision trees and neural networks. We would also look through how the results is visible and how we can understand and interpret the results from SAS. Furthermore, we would also see how we can compare the results of different models in SAS. So let us get started. For this tutorial, I have made use of the letter recognition dataset which I have obtained from UCI repository. This dataset completely contains of 17 attributes and a set of 20,000 instances with the target variable being the letter. This dataset usually makes use of each letter is being pixelated and it has been dimensioned accordingly, and each dimension is used as an attribute in this dataset, with our final problem statement being to find out the type of letter with the set of attributes provided. So let us skim through the data which has been given here. You can see there is completely of 20,000 instances with all the attributes mentioned here. During this tutorial, I would like to explain a set of concepts which is be useful to analyze any set of data. For starters, here you can see that for the letter recognition dataset, I have made use of classification, but not any other set of data mining models such as clustering. The main reason why I have made use of classification is this dataset has been designed as a supervised learning dataset, meaning this data has been retrieved and has been processed for the sake of understanding and figuring out the letter with the help of these attributes. But in case of clustering, we would not be having any classes or any specific range in which we can classify or cluster few models. So in clustering, the average or the set of values present in a data set is grouped together with its properties. So let us start building a classification model in SAS. To do so, let us start by creating a diagram. Let us name the diagram as letter prediction. So let us start by importing the file. To do so, we have to go to the sample tab and click on file import. So here we can see that we have an option to import the file. Let's click on it and select the file. Let's click OK. So after selecting the file, let us click on the variables and see the list of variables present in it. So here we can see the list of attributes which have been used to analyze this model. Here we are going to click on the role beside the letter and we have to change it to target, as that is the target variable for this model. Here we can see the levels has been aligned as interval for numeric variables and nominal for categorical variables. Let us click OK. So let us explore the given data. To do so, we have to go to the Explore tab and select the Explore. So after selecting the Explore, let us link the file import to Explore and let's run the file. So the run status has been completed for Stat Explore. Let us see the results. So here you can see the variable worth of the whole total graph for the list of attributes has been present here. The basic use of Stat Explorer is to provide the mean, median, mode, the skewness, the kurtosis, and other factors which is used for each of the attribute present in the dataset. This explores the data and give us some insights about it, which can be used for further analysis. So let us continue by partitioning the data. To do so, we have to click on Sample and click on Data Partitioning. Let us connect the Stat Explorer to the data partition, and here you can see the split of the dataset allocations here for training, validation, and test. So for this dataset, I'm going to go for 70% of training. Let's give 20 on validation and 10 on test, and let us run this. So the data partition has been run successfully. Let us look through the results. Here you can see the split for each of the validation here. Let us continue by giving some control points for each of the models. To do so, let us go for utility and click on control models. So we have selected the control point. Let us join the data partition to control point. So now let us further continue by giving some neural networks and some decision trees. So to do so, let's click on model and select neural networks and decision trees. So here I have selected the decision tree and neural network. Let us connect both to the control point, which would be using the data partition to analyze. So on the left side, you can see in the property window the set of properties which is used to alter the decision tree models here. Furthermore, if you see inside node, we can see the size of the leaf, the number of rules which would be used, and the number of surrogates which would be used can be handled in this property window. By scrolling down, we can also see there are furthermore options to adjust. So I have already set everything to default to check what would be the analysis report. So let us run this model. To run so, by right clicking and run. So this is the result window of the decision tree algorithm. And here you can see we have a set of curves in different windows, which gives us the cumulative lift of the training and the validation data. By maximizing the output window and seeing through the result, we can see each value has been aligned and its particular observations have been taken into percentages. Furthermore, if you go down, we can see the true positive and true negative window, which is useful to analyze how good this model is. So let us continue by configuring the neural network. For this tutorial, I'm going to make use of the multi-layer perceptron. So looking through the optimization window of the neural network, few important properties I would like to discuss here, which would be one of an important concept here as well, that is the learning rate and the momentum. In general, learning rate is the way or the amount in which the model can analyze the data and understand the values in it. The momentum is considered as the way in which how fast it approaches the algorithm or how much time it's taking or the number of iterations. So this is the final diagram of the classification model with an additional node of model comparison being used here. Before we jump into viewing the results in SAS, I would like to explain few concepts here. To continue with, I would like to explain the difference between the neural network and the decision tree here. The main reason why neural network is better compared to decision tree in this model is a decision tree throws away the input features that doesn't find it to be useful, but neural net will use them unless we do some future selection or a pre-processing step. And next, these sort of classification models such as neural networks and decision tree would not be valid for fat tables where the data has been like used for text mining or spam detection. On such classification, we need to make use of naive Bayes classifier, which is exclusively used to analyze fat tables. Let us look through the results of model comparison. Here you can see the cumulative lift curve being provided for the decision tree and neural network, along with a set of additional factors such as sum of squared errors and average squared error. By maximizing the output, here we can see a set of attributes which is being compared here, such as the average squared error and the misclassification rate. Finally, to explain an important concept here regarding the false negative and false positive. Here we can see a set of four attributes such as false negative, false positive, and true positive. I would like to explain each instance in a very similar way. False negative is such an instant where the data is being classified not as a category, but it is being classified as a category. In a similar way, false negative can be pretty dangerous while computing real-time datasets, due to which it is always best to keep the false negative data to a minimum compared to true negative and true positive. I hope you understood few insights about SAS from this video. Thank you for watching.